A registered jack, RJ, is a standardized telecommunication network interface for connecting voice and data equipment with services provided by network servers and communication service providers. These connectors are crimp-type connectors that are specifically used for telecoms and networking applications. The Bell system introduced registered jacks in 1976, and Federal Communications Commission adopted the new standard as federal law in the 1980s. The RJ platform connections were designed to be much smaller and less expensive alternatives to the previous telephone installation methods of hardwired cords or bulky plugs. Today, RJ45 is probably the most commonly used name to refer to Ethernet cables. The original RJ45 connector was developed as a part of a standardized telecommunication network interface for connecting telephone networks. RJ11, RJ12, RJ14, and RJ45 are among the registered jacks available, with the majority of those on the list are being utilized only in North America. The two numbers following RJ represent the number of positions and pins. The RJ11 and RJ45 are two of the most often used registered jacks in the world. RJ11 connectors are available as one piece, while RJ45 are available in one or two-piece push-in style or pass-through design. It is important to note RJ11 and RJ12 look identical, and the only major differences are how they are wired and the number of the wires that are being used. RJ11 is more widely used than RJ12, which connects 4 pins, whereas RJ12 uses all 6 pins. RJ11 is used in digital subscriber lines to provide broadband internet access and for other home telephone services. RJ12 is generally for wiring corporate PBX, private branch exchange phone systems, and keyed telephone systems. Despite their differences, both wiring standards are used for the same purpose as telephone lines connections, with the center pair being the more commonly used. RJ11 is the most widely used registered jack in voice applications with a 2 or 4 conductor configuration. It is mostly used for voice applications such as single-line phones, ADSL lines, and modern cables. RJ11 can support about 24 megabit per second of bandwidth. RJ11 plugs are square and shorter than RJ45, with a width of 9.65 mm. The commonly used cables to terminate with RJ11 are stranded silver satin telephone cables. RJ45 is an 8-wire connector used with twisted pair cabling for connecting computers, wall plates, patch panels, and other high-speed networking components. The cables that are most commonly used with RJ45 connectors are the Cat5e, Cat6, and Cat6a. Every 8P8C plug used in the RJ45 standard is required to be 21.46 mm long by 11.68 mm high and 8.30 mm wide. RJ45 plugs are able to support both stranded or solid wire with 4 solid and 4 stripe color coding. Pin 1 and 2 are used for data transmission, pin 3 and 4 for receiving data, and the rest of the 4 pins are for communication. RJ45 are used on computers, printers, routers, and switches, IP phones, and cameras, wireless access points, and other devices. RJ11 female jacks and male plugs are wired to conform to USOC numbers originally developed by the Bell system and endorsed by the FCC. Each of the connectors can be wired for different configurations. USOC allows 6-position connector to be wired as an RJ11C, 1-pair, RJ14C, 2-pair, or RJ25C, 3-pair configuration. T568A and T568B are the 2 color codes used for wiring 8-position RJ45 modular connectors. Both wiring schemes are allowed under the ANSI, TIA, EIA wiring standards. The only difference between the 2 color codes is that the orange and green pairs are switched. Both RJ11 and RJ45 connectors require crimp-type tools to terminate to voice and data grade cables. The modular jacks and plugs make use of gold pins, which are used in improving signal strength and maintain optimum conductivity. RJ connector contacts are exposed to moisture, which causes corrosion on the metal surface. Gold is well known for its excellent conductivity and non-corrosive properties. Most plugs are made in gold flash contacts with 3 to 6 microns of gold plating, while quality patch cords and keystone jacks utilize 50 microns of gold plating. Thicker gold plating protects the contact material from corrosion and therefore helps maintain a reliable connection speed for a longer period of time.